This is more fun. Hard to believe. I know. So I want to verify true identities. Good news. Just a little bit. I will tell you the answer to every problem. But it's verifying. It's not proofs. But before we get going, let's go ahead and give me a reminder of all the identities. Jonathan, we'll start over here.
Oh, so,
Just give me one of them.
factory identity.
Yeah, and give me one of these. That's fine.
Oh, you mean the thing?
Yeah.
The thing. Okay, that 9 is equal to 1 over second.
Cosecant. There we go. All right, Andrew. I agree. All right, Sydney. Put the C in there. All right, good. Chloe T. It is. Awesome. Bailey. So they're co. The co's go together. All right. Miss Baldwin. That was one as well. Cotangent of x, 1 over tangent. Just avoiding the quotient ones.
Yeah, I was going to say.
Chloe, you got one for me? Yeah, the reciprocal. Okay, yeah. Make sure you flip it. Secant x is 1 over cosine x. Good. All right, Peyton. Ah, there's one of the quotient ones.
She's a brave girl.
Good. Elisa? Okay, 80.
That's right.
All right, Mason. One more Pythagorean. Ryder? It's the same one as the one right above it. Just take off the cos. You will need to know these forwards and backwards. If that sounds daunting to you, put it on your note card. Put anything you want to on the note card. I don't care. Yeah. No. Oh yeah, we do have some rules for it. Like I said, 3 by 5 inches. No stacking of note cards, so you can't like put a post-it note and post-it notes, so you're sitting there reading through them. Must be handwritten. Not necessarily your handwritten, but no typing it out on the computer, shrinking the font, sharing it with everybody, and everyone has the same thing pasted on there. Right? So it must be handwritten. Huh? Uh, yeah, handwritten. There are some even odd identities. I'm going to skip these for now. I'll come back to them if we need them. I'm trying to think if there was any in the assignment. I'll come back and get some if I need them. I don't think for the assignments I have we need them. No, wait a minute. All right, so here's some strategies, some very basic strategies. This will not get you through all of them by any means, okay? But one of the first strategies I always think of is I always like to change things in terms of sine and cosine. If I have a tangent, change it to sine and cosine. Sine and cosine is going to be a lot easier to work with than maybe a cosecant or secant or cotangent or even a tangent. So that's my favorite strategy right there. And I would actually put that down here towards the bottom, and I would look to put everything in sines and cosines if I don't see something else happening first. Okay. Number two, look to use known formulas for purposes of situations. Use your trig identities that you just told me. Now, they might not be perfect. The Pythagorean ones might not be perfect like you just said. We'll run into that in just a minute. Okay. If you have a fraction, get a common denominator. Okay. Getting everything over one denominator is going to clean up a lot faster. Algebra is going to be fair game. You might have to factor. You might have to, like I said, find a common denominator. You might have to distribute, all that stuff. And if you try something and it just looks like it's not going anywhere, you might have to erase it and try something else. Okay? And that might happen in the notes. All right? There's another strategy. I was just thinking of it while I was going through it. Big one right here. Start with the more complicated side. It kind of seems backwards on it, but it's going to be easier to simplify something down to a side that is less complicated. All right? You guys ready to try it? I only have like 4 examples, so it won't take very long. All right, Jonathan, help me out here. I need to know which side is more complicated. Left side. And most of the time, the left side will be more complicated. Okay? So I'm telling you, the answer to this problem is 1. It's your job to show me step by step how to make that left side convert into 1. I don't want to do this as quick as I can. I know the left side is supposed to equal 1. You have to show me step by step how to get there. Ooh. Yeah, those are all multiplied by each other. If I take cosine of an angle and I multiply it by, if I take cosecant of an angle, multiply it by cosine of an angle, multiply it by tangent of the same angle, it should always equal 1. That's hard to believe, but I'm going to prove it. Yes, and check. Just keep on plugging in different values of theta. No, the domain's being infinity to infinity. So, this is one where I like that very first strategy of change everything to sine and cosine. Okay, I think it's going to be a lot easier to see everything cancel. So, how can I rewrite cosecant in terms of sine and cosine? 1 over sine. How can I rewrite cosine in terms of sine and cosine? Cosine. Trick question. You might put it over 1 because it looks like I'm dealing with some fractions here. Okay, and then tangent in terms of sine and cosine. Awesome. And we're just going to leave the right side alone. Okay. Some math teachers will say, well, you can manipulate both sides to get it down to be the same. Nope. We're going to play with one side, make it look like the other. Okay. So I'm going to go through and cancel some things here. Let's see, sine divided by sine, well, that canceled. And then cosine divided by cosine canceled. I'm left with 1 divided by 1, which is 1. So I told you, the answer would be 1. It's just your job to show me step by step going down how to get there. Well, it has to be in the domain. Like if I do as to do cosecant of 0, it wouldn't work because it's undefined. Good. We can get a little harder, can't we? Sydney, which side do you think is more complicated on this one? I'd say the left side, yeah. All right, so we're going to play with the left side and try to make it look like cosine. Let's try a sine and cosine trick again. Maybe that'll work. So cotangent up here on top in terms of sine and cosine? 1 over tangent? That'd be true. I could work with that if you wanted to. Or I could just use my second quotient identity and write it as cosine over sine. Ooh, I'm making a complicated fraction. And then cosecant in terms of sine and cosine. 1 over sine. That looks nasty. But if I do the keep, change, flip, keep, flip, change, keep, change, flip, I'm taking a fraction, it's cosine over sine. Instead of division, I can change it to multiplication as long as I multiply by the reciprocal. So now the signs cancel. And I'm left with cosine over 1, which is cosine. Oops, I put an equal sign in there. Cosine is equal to cosine. That would, you can cancel the signs. Yeah. What do you think? A couple more?
Oh!
The book is light hard on this. So we need to step it up just a little bit. Which side's more complicated? I'd say the left. And kind of looking at my end goal on this, I'm wanting, this is very similar right here, isn't it? I just got rid of the squared on there. And then I want a tangent on bottom. So I really don't want to change that. I don't want to use that strategy of changing the tangent to sine over cosine. I might if all else fails, but what do you guys see on it? We've already got a common denominator because there's only one. Any algebra we can do on this? Factor it. Exactly right. I could factor it. This is difference of two squares right here. Suppose this was just x squared minus 1. We factored that, haven't we? Instead, it's just sine squared minus 1. So exactly what Chloe said. I'm going to take the sines. I'll split them up. And then I'll take the negative 1. Well, it's a square root, so 1's plus, 1's minus. Okay. What about on bottom? Because that doesn't look like it'll work on bottom. Take out greatest common factor, which is? All right. Let's pull a tangent out of it. Well, that just looks messier. Did I? That's what I want. There's definitely a typo on this one, by the way.
Yeah, I was about to say
I think I would change it in my second here. Let's just make it so it's a plus. Yeah.
okay, now we got one.
All right, now we're good. Yeah, I had the sine theta minus 1 in common in both top and bottom. So that common factor will leave. And I'm left with sine theta plus 1 over tangent. And that's equal to sine theta plus 1 over tangent. One more? Maybe this one's written correctly.
Allow us to start. It's theta plus. Oh, now it's
It's hard to believe that'd be true, right? Cosine theta over 1 plus sine theta is equal to its reciprocal? There might be a sign wrong on this, because I would think there would be a negative, needs to be a negative, but we can see if it works. Any ideas? They are. That makes life easier, because I could have put it up there in terms of, I could have put it up there as secant and cosecant and changed everything. Which side is more difficult? They're both going to be very similar. I'm going to call this left side more similar. Having an addition or subtraction down here in your denominator is going to be a little bit harder to deal with. I could work with the right side though and get there. It wouldn't be just a whole lot harder. But. So the question is, what do we do with this left side? Multiply it by what? Why that?
if you multiply both sides by the denominator one side.
I don't want to multiply both sides though. My rule is on this, we can only work with one side. Multiply by the denominator. Close. I want it to clean up though. Not reciprocal. Start to the C. O. N. J. Not conjunction. Not conjecture. Conjugate. Conjugate. The conjugate. That'll make it so that denominator cleans up nicely. Kind of hurt the numerator a little bit. Now, the beauty of multiplying something by the conjugate is that I got to do the first, and whenever I do the outside and the inside, they always cancel. It does, doesn't it? There's definitely a typo on this one as well. Sorry. I don't know what my deal is. Why I didn't change it last year. All right. It helps. Trust me. It's a great video to record with all these typos in it. Now what? I could factor it out and I'd get right back to where I started. And that 1 minus sine squared, it looks familiar, doesn't it? It is. The first Pythagorean identity said sine squared plus cosine squared equals 1, right? Yeah. And I say at the top, you will know these forwards and backwards because if I subtract sine squared from both sides, 1 minus sine squared must also equal cosine squared. Well, I'm not going to remember them backwards. Put them on your note card. So I can rewrite the whole bottom just as one term. Great strategy, just getting one term down there on bottom. So now I have a cosine on top. That will cancel with one of these cosines on bottom. And I get the right side. Yeah. I'm going to go and change them right now. That's it. You can sit here and watch me work a ton of these, but you just need to practice up. Okay? I'm not too impressed with the book on these, so there's a homework link right here, and for you to practice as many as you need to.